Now we are going to cover a common interview question, a question that I've been asked many times in my coding interviews, and that is a logical problem known as the hats problem. A lot of time I get this question before the actual interview question, the primary interview question, to sort of warm me up. Now, the important thing to do in any logical problem is to draw a picture. I find that this greatly helps visualize the problem at hand. The hats problem is stated as follows. You have three people. Let's label them A, B, and C. They are made to sit or stand in a vertical line back to back, each with a hat on their head, in such a way that A can see the hat of both B and C, but not reverse. B can see the hat of only C. C cannot see anybody. So they're in a straight line and neither of them can turn back around to see the other. They can only see what's in front of them. So the person in the farthest back can see both of them. The person in the middle can only see the front person, and the person in the front can't see anybody. There are three black hats and two white hats totally. When asked to person A if he knows what the color of the hat is, person A is the person in the back who can see both people, he says he does not know. When asked to the person B if he knows what the color of the hat is, he says he does not know. After hearing both A and B, person C correctly says his hat color. How is that possible? Now, you may initially think, wow, this is a very weird problem, and not a lot of information has been given to me, yet somehow the person who can't see anything knows their hat color. How is that possible? Well, we can do this by first assuring you that there's no trick to this and that this is all covered logically. But our next step is to draw a picture. On this slide, I cover our scenarios. So I have person A, B, and C. A can only see B and C, B can only see C, and C can't see anything. And we have three black hats and two white hats. Now, the first piece of information we get is that when asked the person A if he knows what the color of the hat is, he says he does not know. Now, what we need to think about is why would he know what hat he has, and why would he not know what hat he has? Well, if person A was looking forward and saw two white hats on B and C, he would know the two white hats would be out of the equation and that he could only have one of the three black colored hats. So, because that is the only situation where all of our possibilities would be used up and he could know for certain he had a black hat, it means that person A is seeing something different than two white hats. So we know we can take that out of the equation. We actually know that he's either seeing two black hats or a combination of one white hat and one black hat in any order. What we have left is this. We have the three combinations that could be possible for both person B and person C. We could have person B with a white hat, followed by C with a black hat, two black hats on both B and C, and then a black hat on B and a white hat on C. Now that we have again our picture of the three possible combinations we could be in, let's use our next nugget of information. When asked to the person B if he knows what the color of the hat is, he does not know. Now, which situation of these three would allow person B to know his hat color based on what he's seeing from person C? Well, if he saw a white hat on person C, then he could infer that his hat color is black, because that's the only combination. If he sees a black hat color, he could either have a white hat or a black hat. It would be a 50-50 guess, so we would not know for certain. So we know that we are left with our final two combinations. We are left with either B has a white hat and a black hat, or they both have black hats. So this leaves us with our final deduction, and that is we have deduced our scenario to whatever we pick C has a black hat, and that's all we know. So then C can deduce his answer that he does have a black hat, given the information from person A and person B, no cheating. As you can see, drawing these pictures and actually outlining the combinations that were possible at each step helped us out a lot and helped us deduce the answer to this common logical puzzle.